Alright guys, I thought I'd put together a little presentation on the visual field pathways and the deficits that we covered in the lab, just because I know some of you were struggling with that. And this might help reduce the content that we've got to cover in the overview session. But if we take a look at our eyes here, and so one thing to remember with our eyes is that we've got a temporal side and a nasal side. We've got our optic nerves, optic chiasm and tract. And then we've got our LGN, so lateral geniculate nucleus, with our optic radiations to our primary visual cortex, or the striate cortex here. All right, so if we consider the retina here, the back of the eye, in order to process visual information from the right visual field, you've just got to remember that that's going to be hitting the left side of the retina on both eyes. Okay, so right visual field, left side of retina. As you can see from the color coding further back, that information from the right visual field of both eyes has to end up on the left, so the opposite side. And this is going to be true, obviously, on both sides. So if we follow that through, so right visual information on the left eye over here will be coming into the left side of the retina, and it's already on the left side. So that can just come down through the optic nerve, and it doesn't need to cross. That'll just be coming straight through the optic tract. Conversely, it's this information from the right visual field hitting the left side of the retina of the right eye that will need to cross over. So that information will be going through the optic chiasm. Okay. So on the left, it's staying, but on the right, it's crossing. But in both instances, it's information from the right visual field. Now, if we take a look and fill that in with the information from the left visual field, of the left eye, that's going to be hitting this nasal side, whereas on the right eye, it's going to be hitting this temporal side. And again, on the right, it's already on the same side, so that won't be crossing at the optic chiasm, it'll just be going through to the optic tract. Whereas from the left eye, on the left visual field, that's coming into the right side of the retina, going through the optic nerve and crossing. Okay. Now, from the lateral geniculate, we're just going to have the same visual field on both eyes radiating to primary visual cortex. It's a little bit more complicated than this, but we'll get over that. We'll get over onto that in a second. All right, so if we take the schematic and use that to consider what kind of deficits we'll get at lesions at different sites. So if we take a lesion of an optic nerve, it's pretty straightforward. You're just going to lose information, all the information coming from that eye. So here you can see we just have only our right eye still working. Now the next one to consider is going to be a lesion occurring at the optic chiasm. So if we take a look at that in greater detail, what we've got is we've got the nasal part of the left eye and the nasal part of the right eye passing through the optic chiasm. So from the left, that's going to be giving us information from the left periphery, from the left visual field, and from the right eye, that's going to be from the right periphery, from the right visual field. All that information is passing through the optic chiasm, and so if we have a lesion here, we would lose information on the periphery, on both eyes. Okay, so we'd get left with this tunnel vision. Right, if we have a lesion further back, either at the optic tract or at the optic radiations, you can see that it's restricted to one color. So we would have a loss of only one visual field. But you can see if we trace this red backwards, then it's going to be the right visual field impaired from a lesion on the left. Okay, so we'd have loss of the right visual field in both eyes. So if we go through these, we've got a unilateral anopia, so one side unilateral, and it's a complete anopia. If we have an optic chiasmic lesion, that's what's called a bitemporal hemianopia. So bi, because it's both, and it's both temporal sides of the visual field loss, and it's a halving of the visual field, so a hemianopia. If we come back to a lesion at the optic tract or optic radiation, however, what we have is a contralateral homonymous hemianopia. So like I said, a lesion of the left side will affect the right visual field, so that's why it's contralateral. It's homonymous because it's affecting both sides the same, both eyes the same. And it's a hemianopia because we've got a halving of the visual field. So some of you might have covered what's called a quadrantopia in the lab. And to best understand this, you kind of need to look at the same visual pathway from a side-on view. So that's what we've got here. We've got the eyes at the front here. This is the superior and inferior aspect. And when we come to the lateral geniculate and the radiations to primary visual cortex, there's actually two. There's one superior and one inferior radiation. And they convey different portions of the visual field. So if this is the left lateral geniculate and cerebral cortex, then this would be the right visual field conveyed by both. But the superior part would be conveying information from the lower visual field, and the inferior would be conveying information from the upper visual field. Okay. If we just trace that through, so this upper visual field is going to be coming in, it's going to be hitting this lower part of the retina. It'll be conveyed in more inferior fibers through the optic nerve, chiasm, and optic tract to the lateral geniculate. And then from there, it'll go through these inferior optic radiations to the primary visual cortex. In reverse, we'd have the lower visual field being detected by the upper part of the retina, going in more superior fibers through the optic nerve, chiasm, and optic tract to the LGM. And that's going to make its way to the primary visual cortex through these more superior fibers. All right, so if we take a lesion at either of these optic radiations, if it's restricted to just one of these pathways, then we'll get what's called a quadrantopia. So if this is the left side, then we're going to have right visual field loss in either of these. But if it's this lower visual optic radiation, it will be a loss of the upper visual field. So it's called a contralateral homonymous, and it's a superior quadrantopia because we've lost the upper visual field, but just a quadrant of it. And in reverse, if we lose these superior fibers through superior optic radiation, then we lose the lower visual field and an inferior quadrantopia. All right, well, hopefully that helps. If there's interest in these, I might do some more so that we've got little bite-sized chunks of information. But anyway, see you later.